I'm going to show you something you've seen many times before. Yet, looks can be deceiving. You will likely come to a wrong conclusion. What I will show is not what it might look like. Here it goes. This is the most typical and arguably one of the simplest sets of Kubernetes manifests one can imagine. There is a deployment which will ultimately spin up pods containing a single container called main. There is a service that enables communication to the pods, an ingress that enables incoming traffic from outside the cluster, and the horizontal pod autoscaler that scales the replicas, the pods. The only special thing about that explanation is that a part of it is not true. That deployment will not spin up containers, but rather it will run WASM binaries. That solves the biggest issue we're facing with WASM. That makes WASM useful. That elevates it to a completely new level. It changes my reaction to WASM from interesting, yet I don't know what to do with it, to heck yeah. WASM is superior to containers. WASM programs run at nearly native speed. They are smaller in size than their container counterparts, they start significantly faster, they're more secure, and so on and so forth. Yet, WASM did not see a wide adoption. So why is that? If WASM is superior to containers, why didn't we switch to it already? The answer is simple. It is not about containers. The question is not whether WASM is better or worse than containers. The question is whether WASM has the ecosystem needed to provide everything we need to run apps. It's about the ecosystem. We run containers in Kubernetes, and that means that the whole Kubernetes ecosystem is at our disposal. We can use Kubernetes Scheduler to distribute containers across a fleet of nodes. We can use Prometheus, Jaeger, Loki, and Grafana to observe what's going on with those containers running in a Kubernetes cluster. We can leverage Cilium for networking, Argo CD and Flux for GitHub, Skyverno and OPA Gatekeeper for policies, and so on and so forth. Most of the projects in the CNCF ecosystem are designed to be Kubernetes native, meaning that we can pick and choose any of them, and they will all work seamlessly with each other. CNCF alone contains around 200 projects, and that's only a fraction of what we have at our disposal. There's an endless stream of projects and services that are not in CNCF. That's what makes Kubernetes so amazing. It is the biggest ecosystem anyone ever saw, and it is the standard. Kubernetes runs anywhere, and it is offered by everyone. WASM ecosystem, on the other hand, feels insignificant. Anyone wanting to deploy, observe, and manage applications as WASM has to deal with almost non-existent ecosystem. We can use Fermyon Cloud to run WASM, but how can that be compared with AWS, Google Cloud, Azure, Civo, DigitalOcean, and almost any other cloud provider that offers endless number of services designed to run containers? We can run WASM in a single server using Fermyon Spin or even Docker itself, but that cannot be compared with the power Kubernetes brings to the table. Even though WASM is arguably a superior way to run applications, containers, mostly through Kubernetes, have the ecosystem that WASM doesn't. Hence, there are only two parts forward. WASM can create its own ecosystem. That would be fool's errand. It seems very unlikely that WASM's ecosystem alone will be able to reach even 10% of the scope of Kubernetes, meaning that the second path is the only reasonable one. And that second path is to enable Kubernetes to run WASM in the same way as it runs containers today. If we could do that, we would leverage all the power and extensibility Kubernetes gives us, yet with lighter, faster, and more secure runtime than containers. Now, to be clear, that is certainly possible today. Anyone can install WASM runtime on the nodes, configure containerd with Spin or WASM Edge shims, and do whatever else needs to be done. However, that is annoyingly complicated, brittle, and error-prone. I do not want to do any of that. Instead, I would like to have a Kubernetes operator that will do whatever needs to be done to enable Kubernetes to treat WASM applications in the same way as it is treating containers. And that's what Kwasm or Kwasm gives us. Kwasm is a Kubernetes operator that adds WebAssembly support to Kubernetes nodes. It is probably the simplest way to do whatever needs to be done in your Kubernetes clusters so that they can run WASM in almost the same way as they are running containers. Today, we are going to explore three important aspects of running WASM in Kubernetes. We will see how we can enable Kubernetes clusters to run WASM. Then we will explore how to package WASM into container images. And finally, we will see what do we need to change, if anything, in our Kubernetes manifest so that they're running applications as WebAssembly instead of containers. So, let's go. Kwasm makes installation of whatever is needed to run WASM in Kubernetes a trivial operation that consists of 3 steps. First, we need to install the Kwasm operator. Now, that operator does not do anything. It just waits for us to tell it which nodes should be enabled to run WASM applications. We do that by annotating nodes with Kwasm node annotation. That gives us the flexibility to choose nodes from a specific node pool or individual nodes, or as I'm going to do today, all nodes of a cluster. The Kwasm operator is watching for that annotation, and once it detects that a node got it, it spins up a job on that node. The job in turn ran a one-shot privileged pod that installed WebAssembly runtime on the annotated node and did whatever else needs to be done, except for one thing. There is still one more thing we need to do. We need to apply a new runtime class which will tell Kubernetes to use the runtime we just installed. Kwasm supports WASM Edge and Fermyon Spin. We'll go with the latter, for example. Here's the manifest. There is not much here to comment on. There's a name which we'll use in a moment and a handler that, as the name suggests, references which runtime should handle workloads. Let's apply it. And that's it. The cluster is now ready to work with WebAssembly applications just as if they are containers. Now let's move on and see how to package WASM applications. Let's take a look at the code of a silly demo we will run in the cluster. It should not matter whether you're used to write Go code or something else. There's obviously not much going on there, except that we are using Spin HTTP library to handle requests and spitting out a response message. This is a silly demo running on WASM. Now, to compile a spin up into WASM, we need a toml config. This is where we specify application metadata, how to trigger HTTP requests, and how to build it. Think of that file as Spin's equivalent of multi-stage Docker file, more or less. Next, we can execute spin build to build a WASM binary and convert it into a container image and push it to a registry. The last part is important. We packaged WASM into a container image, yet we are not going to run it as containers. I feel it's important to make the distinction between container or OCI images and containers themselves. Container images are a packaging mechanism. They are, in a way, a replacement for zip or tar formats. It's just a package. What makes it special is that it is a standard package. Everyone and everything expects software to be packaged as container images. That, however, does not mean that those images will run as containers. Just as there is no certainty who or what will extract a zip file, there is no certainty who or what will extract a container image. It's just a package, and it's up to a runtime to decide what to do with it. A container runtime might convert an image into containers, while a WASM runtime might extract WASM binary from it. The previous command not only created a container image, but it also pushed it to the TTL-SH. All that's left is to see how we can run that container image that contains a WASM application in a Kubernetes cluster. Let's take another look at application manifests. Those are Kubernetes manifests I used in the past with an application that is running as containers. There is a deployment, a service, an ingress, and a horizontal pod autoscaler. There is nothing special about those except for a single line. The spec entry inside the template that creates the pods has runtime class name set to wasmtime spin v2. It instructs Kubernetes to use a runtime class other than the default one. That's it. That's the only change I did to my manifest. The rest of the deployment is the same. Even though it will run as WASM instead of containers, we can still have a service that enables internal communication to it, an ingress that enables external communication, horizontal pod autoscaler that will scale it up and down, or almost anything else you would normally do in Kubernetes. It works as it's supposed to work, but with a different runtime. I could, for example, push that manifest to a Git repo and let Flux or Argo CD synchronize it. I will not do that, mostly to avoid expanding the scope of this article too much. Instead, we will apply it and retrieve all the resources, including ingresses. All the resources were created, and if you saw only that output, you would never have guessed that those pods are not containing containers, but WASM. As a proof that everything works, we can send a request to the ingress address and observe a silly output. And that's it. That's all there is to it. So let's talk about pros and cons. There are quite a few questions we might need to answer. Should you use WASM? If you should, which runtime should you choose? Where should you run it? I could probably come up with dozens of questions and doubts. I won't go through all of them, partly because I answered some of them in that video over there. The short version is that WASM is a valid replacement for containers, but it has no ecosystem, at least no ecosystem that would make it useful. Kubernetes is the ecosystem, and if we can run WASM in Kubernetes clusters in a way that it is compatible with everything else we do in those clusters, WASM changes from not so good to heck yeah. WASM in Kubernetes is the type of solution we were waiting for. It's what was required for WASM to thrive. We could, for example, use Knative to run serverless applications as WASM. That would increase security, startup time, and performance, while at the same time reducing the size. Or we could run it as standard Kubernetes deployments or stateful sets, or as anything else. We can use whichever method we have to eventually run pods, and those pods can be managing WASM applications instead of containers. That's amazing! The ability to simply change the runtime class in pods is the game changer, and we had that for a while now. What was missing is providers' adoption of WASM. At the time of this recording, only Azure AKS supports WASM out of the box. For everyone else, we need to go through the pain of setting everything up ourselves. And that's where Kwasm jumps in. Kwasm simplifies WASM setup in Kubernetes clusters. With it, we can run WASM in almost any Kubernetes cluster. It works with Azure AKS, Google GKE, AWS EKS, DigitalOcean, Civo, Kind, Minikube, and MicroK8s. Now, that's the list of distributions that were tested, and it should work almost anywhere else as well. The only ones that are known not to work with Kwasm are Oracle OKE and OpenShift. And then GKE is limited to Ubuntu, while it works in EKS if it's based on Ubuntu or Amazon Linux. So there are some restrictions, but not many really. So there's not much bad I can tell about Kwasm. It's a hack of sorts, and that's what it should be. It is not a project that is supposed to exist for long. WASM will soon, and I repeat, soon be available in majority of Kubernetes distributions out of the box, just as it is today in Azure AKS. When that happens, there will be no reason for the existence of Kwasm. But until that happens, Kwasm is amazing. It's bloody amazing. It simplifies a tedious process. It is a setup engine that installs and configures whatever is needed to run WASM on some or all nodes of your cluster. Now, the documentation is almost non-existent, and that's fine, since there's not much to it. It uses privileged containers, which under other circumstances should be illegal, but that's the only way it could access nodes to install the needed binaries. If we would do the setup ourselves, we would need to run privileged pods as well, or to SSH into nodes. Now, there are some limitations as well, but those are specific to WASM, and that's not something we can blame on Kwasm. As a matter of fact, that's not WASM's fault either, since most of those limitations are intentional for security purposes. Depending on which WASM runtime class we choose, we might not be able to mix WASM and containers in the same pod. Hence, sidecar containers attached to WASM might not work, thus making solutions like Istio and Linkerd useless. That's probably the biggest downside of WASM in Kubernetes, which should not be a big deal, since we should be moving away from sidecar containers anyways. Besides, that's not a problem of Kwasm either, but of WASM runtime classes. All in all, Kwasm is an amazing little project that enables us to set up WASM in Kubernetes without going crazy. It allows us to have a glimpse into what will probably become a capability baked into managed Kubernetes clusters. Thank you for watching. See you in the next one. Cheers.